In photography, exposure is the amount of light per unit area reaching a photographic film or an image sensor, as determined by shutter speed, lens aperture and scene luminance. Exposure is measured in lux seconds, and can be computed from exposure value and scene luminance in a specified region. In photographic jargon, an exposure generally refers to a single shutter cycle. For example, a long exposure refers to a single, protracted shutter cycle to capture enough low-intensity light, whereas a multiple exposure involves a series of relatively brief shutter cycles, effectively layering a series of photographs in one image. For the same film speed, the accumulated photometric exposure should be similar in both cases. Photometric and radiometric exposure. Photometric or luminous exposure HV is the accumulated physical quantity of visible light energy per area applied to a surface during a given exposure time. It is defined as where HV is the luminous exposure, F is the image plane illuminance, T is the exposure time. The radiometric quantity radiant exposure here is sometimes used instead. It is the product of image plane irradiancy and time, the accumulated amount of incident light energy per area. Where he is the radiant exposure, EA is the irradiance, T is the exposure time, if the measurement is adjusted to account only for light that reacts with the photosensitive surface, that is, weighted by the appropriate spectral sensitivity, the exposure is still measured in radiometric units, rather than photometric units. Only in this appropriately weighted case does the H measure the effective amount of light falling on the film, such that the characteristic curve will be correct independent of the spectrum of the light. Many photographic materials are also sensitive to invisible light, which can be a nuisance, or a benefit. The use of radiometric units is appropriate to characterize such sensitivity to invisible light. In sensitimetric data, such as characteristic curves, the log exposure is conventionally expressed as log 10, h. Photographers more familiar with base 2 logarithmic scales can convert using log 2, h, a per mil 3.32 log 10, h. Optimum exposure. Correct exposure may be defined as an exposure that achieves the effect the photographer intended. A more technical approach recognizes that a photographic film has a physically limited useful exposure range, sometimes called its dynamic range. If, for any part of the photograph, the actual exposure is outside this range, the film cannot record it accurately. In a very simple model, for example, out-of-range values would be recorded as black or white rather than the precisely graduated shades of color and tone required to describe detail. Therefore, the purpose of exposure adjustment is to control the physical amount of light from the subject that is allowed to fall on the film, so that significant areas of shadow and highlight detail do not exceed the film's useful exposure range. This ensures that no significant information is lost during capture. It is worth noting that the photographer may carefully overexpose or underexpose the photograph to eliminate insignificant, or unwanted detail. To make, for example, a white altar cloth appear immaculately clean, or to emulate the heavy, pitiless shadows of film noir. However, it is technically much easier to discard recorded information during post-processing than to try to recreate unrecorded information. In a scene with strong or harsh lighting, the ratio between highlight and shadow luminance values may well be larger than the ratio between the film's maximum and minimum useful exposure values. In this case, adjusting the camera's exposure settings only allows the photographer to choose between underexposed shadows or overexposed highlights. It cannot bring both into the useful exposure range at the same time. Methods for dealing with this situation include using some kind of fill lighting to gently increase the illumination in shadow areas, using a graduated ND filter or goba to reduce the amount of light coming from the highlight areas, or varying the exposure between multiple, otherwise identical, photographs and then combining them afterwards in some kind of HDRI process. Overexposure and underexposure. A photograph may be described as overexposed when it has a loss of highlight detail, that is, when important bright parts of an image are washed out, or effectively all white, known as blown-out highlights, or clipped whites. A photograph may be described as underexposed when it has a loss of shadow detail, that is, when important dark areas are muddy, or indistinguishable from black, known as blocked-up shadows. As the image to the right shows, these terms are technical ones rather than artistic judgments. An overexposed or underexposed image may be correct, in that it provides the effect that the photographer intended. Intentionally over or underexposing is casually referred to as shooting to the right, or shooting to the left, respectively, as these shift the histogram of the image to the right or left. Exposure settings, manual exposure. In manual mode, the photographer adjusts the lens aperture and/or shutter speed to achieve the desired exposure. Many photographers choose to control aperture and shutter independently because opening up the aperture increases exposure, but also decreases the depth of field, and a slower shutter increases exposure but also increases the opportunity for motion blur. Manual exposure calculations may be based on some method of light metering with a working knowledge of exposure values, the apex system and/or the zone system. Automatic exposure. A camera in automatic exposure mode automatically calculates and adjusts exposure settings to match the subject's midtone to the midtone of the photograph. For most cameras this means using an onboard TTL exposure meter. Aperture priority mode gives the photographer manual control of the aperture, whilst the camera automatically adjusts the shutter speed to achieve the exposure specified by the TTL meter. Shutter priority mode gives manual shutter control, with automatic aperture compensation. In each case, the actual exposure level is still determined by the camera's exposure meter. Exposure compensation. The purpose of an exposure meter is to estimate the subject's midtone luminance and indicate the camera exposure settings required to record this as a midtone. In order to do this it has to make a number of assumptions which, under certain circumstances, will be wrong. If the exposure setting indicated by an exposure meter is taken as the reference exposure, the photographer may wish to deliberately overexpose or underexpose in order to compensate for known or anticipated metering inaccuracies. Cameras with any kind of internal exposure meter usually feature an exposure compensation setting which is intended to allow the photographer to simply offset the exposure level from the internal meter's estimate of appropriate exposure. Frequently calibrated in stops, also known as EV units, a +1 exposure compensation setting indicates 1 stop more exposure and a €1 means 1 stop less exposure. Exposure compensation is particularly useful in combination with auto exposure mode, as it allows the photographer to bias the exposure level without resorting to full manual exposure and losing the flexibility of auto exposure. On low-end video camcorders, exposure compensation may be the only manual exposure control available. Exposure control. An appropriate exposure for a photograph is determined by the sensitivity of the medium used. For photographic film, sensitivity is referred to as film speed and is measured on a scale published by the International Organization for Standardization. Faster film, that is, film with a higher ISO rating, requires less exposure to make a good image. Digital cameras usually have variable ISO settings that provide additional flexibility. Exposure is a combination of the length of time and the illuminance at the photosensitive material. Exposure time is controlled in a camera by shutter speed and the illuminance by the lens aperture and the scene luminance. Slower shutter speeds, and greater lens apertures, and higher luminance scenes produce greater exposures. An approximately correct exposure will be obtained on a sunny day using ISO 100 film, an aperture of f/16 and a shutter speed of 1/100th of a second. This is called the sunny 16 rule. At an aperture of f/16 on a sunny day, a suitable shutter speed will be 1 over the film speed. A scene can be exposed in many ways, depending on the desired effect a photographer wishes to convey. Reciprocity. An important principle of exposure is reciprocity. If one exposes the film or sensor for a longer period, a reciprocally smaller aperture is required to reduce the amount of light hitting the film to obtain the same exposure. For example, the photographer may prefer to make his sunny 16 shot at an aperture of f/5.6. As f/5.6 is 3 stops faster than f/16, with each stop meaning double the amount of light, a new shutter speed of /2 /2 equals 1/1000 is needed. Once the photographer has determined the exposure, aperture stops can be traded for halvings or doublings of speed, within limits. The true characteristic of most photographic emulsions is not actually linear, but it is close enough over the exposure range of about 1 second to 1/1000th of a second. Outside of this range, it becomes necessary to increase the exposure from the calculated value to account for this characteristic of the emulsion. This characteristic is known as reciprocity failure. The film manufacturer's data sheets should be consulted to arrive at the correction required, as different emulsions have different characteristics. Digital camera image sensors can also be subject to a form of reciprocity failure. Determining exposure. The zone system is another method of determining exposure and development combinations to achieve a greater tonality range over conventional methods by varying the contrast of the film to fit the print contrast capability. Digital cameras can achieve similar results by combining several different exposures made in quick succession. Today, most cameras automatically determine the correct exposure at the time of taking a photograph by using a built-in light meter, or multiple point meters interpreted by a built-in computer, see metering mode. Negative print film tends to bias for exposing for the shadow areas, with digital favoring exposure for highlights. See latitude below. Latitude. Latitude is the degree by which one can over, or underexpose an image, and still recover an acceptable level of quality from an exposure. Typically, negative film has a better ability to record a range of brightness than slide transparency film or digital. Digital should be considered to be the reverse of print film, with a good latitude in the shadow range, and a narrow one in the highlight area. In contrast to film's large highlight latitude, a narrow shadow latitude. Slide transparency film has a narrow latitude in both highlight and shadow areas, requiring greater exposure accuracy. Negative film's latitude increases somewhat with high ISO material, in contrast digital tends to narrow on latitude with high ISO settings. Highlights. Areas of a photo where information is lost due to extreme brightness are described as having blown-out highlights, or flared highlights. In digital images, this information loss is often irreversible, though small problems can be made less noticeable using photo manipulation software. Recording to RAW format can ameliorate this problem to some degree, as can using a digital camera with a better sensor. Film can often have areas of extreme overexposure but still record detail in those areas. This information is usually somewhat recoverable when printing or transferring to digital. A loss of highlights in a photograph is usually undesirable, but in some cases can be considered to enhance appeal. Examples include black and white photography and portraits with an out-of-focus background. Blacks, areas of a photo where information is lost due to extreme darkness, are described as crushed blacks. Digital capture tends to be more tolerant of underexposure, allowing better recovery of shadow detail, than same ISO negative print film. Crushed blacks cause loss of detail, but can be used for artistic effect. See also, bulb, exposure bracketing, exposure value, film speed, gray card, high dynamic range imaging, light painting, light value, long exposure, multiple flash photographic technique, multiple exposure, night photography, sensitometry, shutter speed, zebra patterning. Notes. References. External links, media related to exposure at Wikimedia Commons.